Hello friends, welcome to the session on digital image processing. In this session, we'll be discussing about one of the important technique in digital image processing called as the image restoration. In this session, we will see what we mean by image restoration, how it is possible to restore the degraded image, and also we will see the different noise models that are available in the MATLAB or Scilab. Friends, as you know that you are viewing this session on my YouTube channel, and you can always subscribe to the channel so that you can watch many other educational videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by image restoration. So as we know, any digital image can be represented by a two-dimensional function, and this two-dimensional function can be written as f of x comma y. This two-dimensional function will return us a value, and this value will correspond to the intensity or gray level at the coordinates x comma y. So any digital image is basically a collection of pixels, small points called as the pixel, and every pixel will have a certain gray level or intensity value, and this gray level or intensity value can be described by a function f of x comma y, and this function can be written in the matrix form. So once you are able to write a matrix for given image, then it is always possible that you can perform the different matrix manipulation on these images. Let us understand what we mean by the image restoration. Many times you will find that the image that is being provided to us is not appropriate, and we need to make some improvement in the image. So such improvement in the given image in the predefined sense can be achieved, and so this is to be called as the image restoration. So restoration will attempt to recover or reconstruct the image. So the given image, if it is degraded by some prior knowledge, means we must know what is the reason behind the degradation of the image. And if we know the degradation of the image, then it is possible that such degradation can be recovered by using the restoration techniques. So in the restoration, we model the degradation and will apply the inverse process so that we can recover the original image. Say for example, if we have been given a very blur image, and then if you want to recover the original image, then that can be achieved by using the de-blurring function. So when you apply this function to this image, then the blurred image can be recovered, and this can be called as a restoration. So the whole process of restoration can be shown by the diagram. Suppose this is the input image f of x comma y, and suppose we apply some degradation function h to this image, and suppose some noise is also added into the image so that we will have a further degradation of the image, so that we will get the image g of x comma y. Then we can apply the restoration filters to this image so that we can get at the output the original image f of x comma y. So the restoration technique will consist of the two parts. The first one is the degradation part, and the second one is the restoration part. As far as this session is concerned, we will discuss only what are the different noise models that are available in the Scilab or MATLAB. So whenever we think of any noise models in the Scilab or MATLAB, then you will find that it is possible that you can add the noise into the given image by using this function called as image noise or IM noise. So there are different types of noise that can be added. Say for example, we can add salt and pepper, we can add speckle, we can add Gaussian noise, we can add the local variable where we can have a pixel specific variance, we can add Poisson, or we can add the noise in relation with the parameters. So this function will have a format. Imn is equal to im noise, in the bracket we write im comma type, and then there are different parameters in the square bracket. So you will find that the im noise is the returned image or output image, which will consist of noise, and im is the original image. So we can add the different types of noise. So for example, when we think of adding the salt and pepper, then this noise will just nothing but a dropout noise. So it is possible that we can have a probability of swapping the pixels and the default value for this D is 0.05. We can add the Gaussian noise, which is an additive noise, and you will find that it will have an additive noise of the mean M and variance V. So the default values that are being used for the mean and variance are 0 and 0.01. We can add the noise by using the local variable. So this is an additive zero mean Gaussian noise. We can add the noise by using the intensity value by using the local variable. We can add the noise by using speckle. So there are different formats available, and with the help of these formats, it is possible that we can add noise into the image. So for example, this is the original image, dog image, n1.jpg. And suppose I add a noise Gaussian into this image, and then you will find that this image will get converted into this image, where one can easily observe that the noise is being added. If we change the type of the noise to salt and pepper, then you will find that the image will look like as shown in this window. If you specify some more parameters for this salt and pepper, and then you will find that the more noise will be added into the image as shown in this window. It is possible that you can define a specific triangle. So for example, if I want to add the noise in the lower part of the image or lower triangle of the image, then I need to write this local variable as shown in this statements. And then you will find that the lower part of the image will consist of the noise. So thank you friends for viewing the session. Hopefully you have understood what is the restoration technique and how it is possible to add noise into the image. Thank you all.